It's still physics time. You thought you'd escape it, but it seems like it never ends. Oh my goodness. We've got impulse momentum application problems here. All right, this is a super traditional way that you can tie the idea of impulse, which is how you change momentum, and the results of changing the object's momentum, which usually ends up in changing its velocity and things like that. So here is one of my personal favorite problems where you have some sort of tennis ball or something like that. I should probably draw a tennis ball. Woo, tennis ball. Look at that. It's tennis ball. Okay, baseball would have the lines on it, but it's tennis ball. All right, and so it's coming in. It's coming pretty fast. So let's say it's coming with a velocity of 25 meters per second. And let's say it's got a mass of 0.2 kilograms, which is a really heavy tennis ball. But hey, it's how I work out. And so it's coming in, and then someone's like, I will hit it with a racket. Who would have thought, hitting a tennis ball with a racket? So you have this racket over here. All right, so racket is going to swing and hit it. All right. Tennis racket. Tennis racket. All right, so tennis racket. All right, so it's going to hit it. So here's the deal. So it comes in, it's moving like this, but then the thing is, what happens after the tennis racket hits it? I don't know why, but I have this desire to put a second round on this. I feel better now. Okay, so the tennis racket hits the tennis ball, and so now this is basically your before situation. All right, tennis ball's coming in, then afterwards, something happens, and shockingly, the tennis racket has now hit the tennis ball, and so now it's going the opposite direction, and it's going 30 meters per second. So, and its mass is the same, so I'm not going to write its mass again, but I have to, for some reason, draw another tennis racket. I don't know why I didn't just hit copy and paste, but okay. So tennis racket is crushing the tennis ball. It's going to go in the opposite direction. All right. All right, do. And then these are that's the worst circle ever. Okay, I will be judged by that, I'm certain. And my first tennis racket was so much better than my second one. It looks like a mirror you'd look into. Oh well. So here's our tennis racket. So here's our after scenario. And we want to know one major question, and that was, what force did the tennis racket apply to the ball? All right, so that's the question we are trying to solve, and to do that, we are basically going to use our law of, or it's not really a law, it's just the impulse momentum theorem. All right, so one thing we need to know is, let's say that the tennis racket was in contact with the tennis ball for a whopping 0.05 seconds. All right, so that's how long the tennis racket was in contact with the ball when it smacked it. Okay, so we want to know, well, what force did it apply? And so we're going to use our impulse momentum theorem, which states that the impulse applied is equal to the object's change in momentum. Well, we can redistribute this as impulse is force times change in time, and change in momentum is equal to mass times change in velocity. Well, okay, it seems promising here. So we're looking for the force, so we leave that as an unknown. The time was 0.05 seconds. And then we need to know the mass. Oh, there's the mass of 0.2. And then velocity. It's a change in velocity. And this is where students make the big mistake. It's not a velocity, it's a change in velocity. And just in case you have forgotten, change in velocity is equal to your final velocity minus your initial velocity. So the final velocity was 30. Now, velocity cares about direction, so this was 30 to the left, so I'm going to call that a negative 30. All right, minus my initial velocity, which was 25 to the right, so it's a positive 25. So now if you look, this is just an algebra problem. So when I do all my math, I'm going to get a force equal to negative 220 newtons. Now I know that normally when we do forces we don't have the negative sign, but notice I did not draw a force diagram for this. So I don't know which way the force is pointing going into this. And the fact that I have a negative here is telling me that this is a force that's applied to the left, which makes sense because if I were to draw the tennis ball, I'd be like, hey, well, here's my tennis ball. All right, what forces are acting on the tennis ball? Well, it was initially moving to the right, but now it's moving to the left, so therefore we must have had some sort of force acting on it. So force normal on the ball by the racket. QET, racket. All right, so it's got to go to the left, and thus that's where the negative sign shows up. So this does tell me the direction. And so a lot of students will not take this last step to say, hey, wait, does my force make sense? So if you do this math and you never drew a force diagram, so you never brought direction into play, then your force that you get from this equation should tell you which way it's going based on positive negative. So I'll have students draw these pictures and they'll miss up the math somehow, or they'll do instead of final mass initial, they'll do initial mass final. They never did the negative signs, like, oh, I got a positive value, I'm done. Well, that makes no sense because in order to send it left, you have to have a force pointing to the left. So that makes sense, then it should be a negative. So take the time to use your conceptual understandings of physics to check your work. Don't just blindly do the algebra, because shockingly, I will probably give you an assessment that will force you to use a lot of negative signs. You know how much I love to do that, just to really push your buttons and check your true understanding. So take that last minute and double check yourself. But it's a really simple process because you're saying, hey, I draw before, I draw an after. Let's keep track of directions and things like that. Impulse momentum theorem just says the impulse applied is equal to the change in the object's momentum. Well, how do you apply an impulse? You apply a force for a period of time. How do you change an object's momentum? Well, you take its mass and you change that velocity. So it's really a plug and chug type problem as soon as you identify what's going on and you make that picture. So take the time, draw the picture, use the theorem appropriately, and find success. Booyah. All right. So live long and game on.